on. Okay, perfect.
Tell us that it's starting.
Okay. So I will wait.
Maybe not. We want to see it. So I'm going to just start myself. It's not starting to see it.
Okay, so yeah, okay, we're rolling. So I don't know if it's on the agenda, but I'm Fatima Brown. I'm collaborating with Mike Poole from Amazon on today's conversation, and we're going to be talking about managing truth in a knowledge graph. But I think some useful background before we dive in is Mike and I have worked together for nearly a decade now in a variety of contexts. And today's topic on grappling with some issues around truth and the complexity of delivering knowledge graphs for large organizations is something that's been top of mind for us throughout that entire process. But I will say one element that's been particularly exciting for me, though, as a social scientist, and what I think is finally getting its due traction, is not only the conversation around accuracy issues that plague AI, but also the issues and concerns around bias, and specifically around how we manage and curate knowledge, how we instantiate things like truth, right? So what we're proposing today is a tactic, a strategy for ameliorating some of the concerns around truth and knowledge management and AI tooling. And we're asking you to, I think what Deb McGinnis was saying a little bit earlier is to, we're going to sort of push some of the prevailing assumptions and design patterns around how we should traditionally think about deploying large knowledge graphs. And then we have time for questions at the end. So we start here with deliberately and intentionally provocative quote. And it's meant to, what we're not saying is that inconsistency is something that should be considered valuable in and of itself, right? What we're pushing for, again, is let's just push the edge of the conversation. Let's think about some of those prevailing design patterns and how we might be able to leverage or embed more advanced kind of, or a different way of modeling for knowledge, right? So what extent might we want to consider giving up some things like striving for global consistency in order to gain a little bit more knowledge representation flexibility, but also consider to the extent that perhaps having a single ontological perspective might impede some of the ways that we need to deploy knowledge graphs for business requirements. Okay, so pretty brief outline of the conversation. So we're going to start with just diving into some of the challenges with truth in AI and kind of the general problem and opportunity as we see it. And then we're going to switch over to knowledge graphs, not only kind of that history and kind of that kind of standard or traditional design approach and how we view silos, but also looking at the opportunity that what can we leverage from some of the features from the way that silos have manifested. And then lastly, we're going to dive into a technical conversation on building out this new design pattern. Well, not really new, but an alternative design pattern called knowledge context. So this is how we kind of see the core problem with truth in AI and large language models. And what we're trying to do is we're asking these inherently biased processes and tools to generate truth statements, right? And part of the challenge and the opportunity with that is we haven't done sufficient work to really unpack our complex physiological and sociological relationship with truth. So not only have we not really unpacked that things like truth can be contextual, we also don't really have reliable mechanisms for enforcing truth in AI systems. And that's why we're thinking about knowledge representation methods as a way to kind of ameliorate some of these issues that we're trying to solve with truth. So just a few of what we see as challenges, but really opportunities, right, for all of us who are working in knowledge. So the first item, top of line, is truth can be contextual. We can have some additional conversation, and some other folks at the conference might want to unpack that a little bit more. But bias is embedded into the process. It's embedded into the process, it's embedded into the workflow, right? So if we think about the nature of how large language models work, they're not designed for truth, right? So large language models are pattern detection, pattern reinforcement tools. And that's how we get some of the issues that have kind of surfaced around hallucinations. And then there's the additional challenge of aligning large language models with human values. And we won't really dive into some of those details today, but I think other folks might. But these are things to kind of start provoking thinking about how we as knowledge engineers and folks who are interested in knowledge representation, how we might align ourselves to help advance the work of large language models. And then thirdly, solving large language models isn't simply a matter of throwing more data at the problem. And we have some thoughts around why that might be. Like, for example, if we think about the way that large language models work versus the way that sort of a logic-based system works, right? Where we actually have these mechanisms, we have ontologies that are grounded in truth, and a mechanism for enforcing truth in downstream applications. Whereas the opportunity with large language models is that they do require some type of, they have a heavy dependency on some knowledge source, but that they also require some type of grounding in truth. And that's where potentially semantic networks can serve as a back end to that workflow and serve as a way to enforce some of the truth, but also serve as a model validator and a model trainer. And that's related to the last item here that, large language models they're not fact sources, and they're not generating knowledge, right? So and I think Deb kind of touched on this a little bit, there's an element of reasoning that's happening, and we won't quibble about that in today's conversation, but if we're thinking about the sort of an ideal workflow, it is this thing where we can say, hey, we can ground large language models with a knowledge graph, and then in that way we can kind of enforce some of the output to generate more true statements. Okay, so I touched on some of these things, right? So everything that I've positioned kind of at the front of the conversation is ways that knowledge graphs can potentially help improve accuracy and confidence levels of the data. Right, but we're going to have to revisit some of the things that we might consider to be sacred cows in this space. So some of the sacred cows in this space are that knowledge graphs should serve as a single source of truth, that knowledge graphs should be designed and deployed with sort of univocal definitions, and that we should always strive for global consistency. And we will have we'll dedicate a bit of the conversation to looking at, what are the actual ways that you can deploy these that isn't too aggressively and not too naively, so that way you can actually impact your business and gain buy-in for deployment within your organizations. And then also some specific semantic web approaches for helping with the interoperability issue. What are some ways that we can, leverage semantic web standards to, exploit the ability to leverage your ontology for inheritances, right? So that way you're grappling with some of those inconsistency challenges, but then also making sure that you can contextualize appropriately. So I'm going to hand the conversation over to Mike, and he's going to walk us through some of those key technical points.
So we as Shima indicated, we want to kind of think a little bit more about truth and the way we can do some of the stuff that Deb was talking about this morning. How do we leverage a knowledge graph to help us validate and address situations in which we're using LLMs and we want to make sure they're getting things right. We want to feed it accurate information and that sort of thing. And one of a couple of the sacred cows that we want to address is this notion that what's the big advantage of a knowledge graph? Well, we often hear two things, right? The one really big thing is knowledge graphs are a single source of truth, right? We create a knowledge graph, and the whole enterprise, or the whole, whoever's using this knowledge graph, we're going to have one place to go look up definitions, and one standard of meaning is enforced. And you go do a search on the advantage of knowledge graphs. That's one of the key things that they emphasize. The other thing is the eradication of semantic silos. Semantic silos are bad. We need to eliminate them, and that's what a knowledge graph is going to be good for. And I guess what we want to say is, it may be useful to think about knowledge graphs in a slightly more flexible way. So there is obviously some utility in having a kind of a standardized ontologies in place. It's obviously useful that we can eradicate some of the barriers between our data sets, but how far, how do we do that in a flexible manner? So let's think first quickly about the notion about semantic silos, why they exist in the first place. And there's a few advantages that they provide, right? One of the things is in a semantics, if we have our data in different places, or if we have these so-called silos, it actually allows for the fact that, in fact, different data users have different data requirements. They need different levels of flexibility or accuracy or updating speeds, or different properties are relevant to them. The other advantage of kind of keeping our data in all kinds of different silos is the ontology that one needs for that may differ from place to place, the kinds of things you're reasoning about. And finally, in this non-knowledge graph world, the one useful thing that we have is flexibility in terms of updating the model, right? Like, I don't have to talk across the organization and have this big discussion. We can just update our model. So we're not saying semantic silos are awesome, but we're saying there's a few reasons that they're there. They give us some flexibility, and that's something that it might be nice if we could salvage some of that. And of course, anybody who's tried to build a sort of enterprise-wide ontology knows that's really hard to do, right? There's often what we call the ontologist bottleneck. It takes a long time for ontologists to get together and figure out the different meanings of things across the firm. And in fact, there's a brittleness problem too, right? That there's maybe very specific reasoning requirements in one place that aren't needed in another. So sometimes let's suffice it to say, it can be very challenging to build a single model of truth. But all that said, we still think knowledge graphs are really important, right? They allow us to kind of break down these barriers. We allow us to analyze across the organization. It does allow us to go somewhere and say, what does this person mean by this? Or what is the standard meaning for this? Or where can we leverage our semantics? So it's obviously not the case that we say knowledge graphs are bad, we should go back to where it came from. We obviously want to wring these things out, but also see if we can leverage some of the flexibility that we get from not overemphasizing trying to create one single enterprise-wide ontology. So that's a little bit what we want to talk about today. And we're gonna do kind of a three bears on this. Is if we look at the development of large knowledge graphs, or this attempt to kind of create this situation where we can integrate all our data in one place, there's been, I would say, two key approaches. I'm gonna somewhat, maybe unfairly, characterize one as the DBpedia approach. The second one is the FIBO approach, and then we're going to propose what we call our federation and contextualization approach, right? And the DBpedia approach is really one of saying, we're going to create an ontology that's really kind of lightweight, right? Makes it a lot easier to pull all kinds of data in, and that's relevant if we're looking at DBpedia, which is trying to integrate data from the web that comes in from Wikipedia. Well, the data quality of that varies, the accuracy varies. So the solution seems to be, we'll create a very lightweight ontology, which does help. Like DBpedia has a huge, vast, diverse knowledge set, a very, very large knowledge set. But we can't do some of the sexy things that we want to do with ontologies, right? The ontology isn't very rich. The RDF OWL there really just kind of plays a data structuring role, doesn't really allow us to build very rich semantics. The flip side of that is the FIBO approach. If any of you have looked at FIBO, you know it's actually an amazing ontology, like incredibly detailed, very, very accurate. We've got a lot of experts who spent a lot of time building this really, really good sophisticated ontology representing concepts that we need to know for the finance domain. Of course, the obvious challenge with FIBO is it took a long, long time to build it. And the second challenge with that is if you want to start integrating your data sets against it, not trivial, right? It's a little bit, it's fairly hard to do. So we want to contrast what we call the third way, And what we want to emphasize is basically some semantic web standards that have been evolving over time a little bit, and particularly the utilization of name graphs. Our contention is that we haven't exploited them as much as we could have. We want to exploit shackle and leverage OWL import so that we can create hierarchies of ontologies such that we have a general ontology at the top, and we can create more domain-specific ones that work out in different places. So I'm going to give, and we're a little bit rushed for time, but I'm going to actually dive into a formal specification of what a knowledge context is. And a knowledge context is a set of name graphs, a set of data sets, let's say it. It's a set of ontologies, and it's a set of shackle shape files, right? So that's the key idea. So a knowledge context is we can specify any old knowledge context. We can say it's these data sets, these ontologies, and these shackle shape files. And of course, we can create, what this means is we can create more than one knowledge context in our knowledge graph. A knowledge graph can now be composed of a bunch of knowledge contexts. And an ontology can be reused across different knowledge contexts, of course, but it doesn't have to be. Similarly with your shackle shapefile. So what does that allow us to do? So with what we say within a context, I think is sort of natural things to people doing ontology. We say within a context, you're committing to logical consistency. The whole ontology has to be consistent. You're committing to the truth of the entailments that can be derived from your ontology, and you're committed to the data quality commitments articulated in your shackle shape set. Okay, you can, however, have inconsistency in ontologies that are covering different contexts. So ontology 1 in context 1 can be inconsistent with ontology 2 in context 2. That's what we want to suggest. And then what does this mean for creating the knowledge graph? Well, your shackle validation is done contextually, right? You validate your data only with the shackle shapes relevant to that context. If the reasoner is off, we can still query across our entire graph, whatever you want to do. Turn the reasoner on, and you have to now start paying attention to context, right? You have to say, okay, I can only apply this set of ontologies here, etc. So most of our knowledge graphs are set up to create a single T-box. What we would suggest is this may take some engineering that allows us to flip around to different contexts, but this is kind of what we would propose to make this work. So I want to rush through this to give you a couple concrete examples. Here's a nice example kind of from my banking background, where a bank comes in and they say, I want to buy customer data from a couple different external sources. So we have this scenario in which I've got an ontology that says every company has a maximum of one ultimate parent. I buy data from Refinitiv, and it says Acme Inc.'s ultimate parent is Big Acme. I buy data from Tibco, and it says Acme Inc.'s ultimate parent is Large Acme. Now, my ontology says every company can have only one parent. I put these together in one knowledge graph, and what happens? I'm going to get an inconsistency because Acme Inc. now has two ultimate parents according to my data set, and I run into an inconsistency. So obviously here we're proposing that we would create context, right? We have a Tibco context, but they can use the same ontology, but we reason differently in the context. And we can say, I can make sure that my Tibco data is locally consistent. I can make sure that my Refinitiv data is locally consistent, and I'm not going to jam up my reasoner and generate inconsistencies. I'm going to rush through a couple of these because I'm sort of running out of time. But another kind of key use case here is if we think about ontologies expressing meaning, like our ontology might say every US person has a social security number. Now, if we're trying to apply our data, that rule, we may want to enforce it if we're in the tax department. We want to say, yeah, everybody has to have a social security number. But if we're creating the data that's going to be posted on the internal directory, we don't want to post people's social security number. Again, handle that with context. Context 1 requires a social security number. So context 2, it disallows it. You can't have it. So, and I want to look at, I have a number of different things. The other kind of key scenario, I'm racing the clock here. Another kind of key scenario is when we have different definitions. I'm going to just pick out my favorite here. So here's a definition. I'm at Amazon now, a real definition that we actually have to deal with. Vodka in the UK, in the US, is defined as having at least 40% alcohol. In the EU, it's defined as having 37.5% alcohol. So here is my notional knowledge graph. I've got this graph. It has a general ontology at the top that's shared across the firm. And in my different divisions of different ontologies, and within division 2, I can actually have different ontologies again for the US, Europe, and Australia. And then underneath that, I've got my data sets. Now let's look at my reasoning scenario. My division 2 is worrying about product knowledge. In my division 2 ontology, we say vodka is made from potato or grain. In US, I say it's got to be at least 80 proof. Europe, I say it has to be at least 75. In my product data, I've got Schrodinger's potato vodka at 78 proof, right? So what do we do with this? Well, I now create a Europe context, and now I can run a query in my Europe context. Is Schrodinger's vodka? Yes, it is. But then I switch over to my US context. I say, is Schrodinger's potato vodka? It's not, because it doesn't reach the proof requirement. So this is kind of like a simple example of how you would kind of create different contexts to allow for the challenges of integrating these different data sets. So anyway, armed with this, we contend that we now have the flexibility to use our KGs to handle the kinds of things that come up in kind of validating and handling truth in an AI. So, all right, I'll stop there. Yeah.
I don't know. We started late.
Sorry, is there a reference paper on the approach here, or is it just the slides?
It's just slides at this point. Yeah.
I find the presentation extremely interesting. I have a question which echoes the kind of thing I'm going to talk about tomorrow, which is about validation versus refactoring. Because my understanding of what you are proposing is that you can take whatever you want in a knowledge graph, and then instead of refusing data which is not consistent with your predefined model, you allow for light refactoring of the data so that you can present it the way that is needed, but you don't have this bottleneck of refusing data which is not consistent. Is that a proper understanding of your approach? Or?
Yeah, very much. Like in fact, I would say that in many of these cases, like the Refinitiv TIBCO case, we actually wouldn't want to cleanse our data beforehand. We actually want to see what Refinitiv says, and we can retain it there in that space. So we want to actually avoid data cleansing and be able to pull, or as you say, or we may want to dumb down our ontology to allow that data in, and it's there, and we do different validation in different places. Did you? Yeah.
Summarized nicely.
Dan, did you?
The context of an IRI.
That's a good question. I don't know. I would say to the question of whether we've spelled this out more formally, I would say yes. Like I would turn that into. I would want the context to be like a full blown object in the graph that we would define. So yeah. So we haven't deployed this in an actual graph, but yeah, I think it would be. I think it's more metadata that we would store in the graph. Yeah, it's a good question that we should have thought of.
For more, or are we done? Oh, we're done.
1 minute.
Not till 11, so you have half an hour. So you can, no rush.
Threats running around, but yeah, that's good. Were you there on the keynote? I was there after both this morning. Yeah. I'll be here most of the day. Yeah, I should be here all day. I just have to leave. I have to try to figure out with my wife where I need to go. Stay as long as I can. All right. Yeah. Yeah. Yes. Yeah. Yeah. Yeah.